Class opener. The vertex is either the what? Lowest or highest, right? I'm going to go highest or lowest point of the parabola, depending on if it opens what or what? Up or down. That makes total sense, right? Okay, how about this? The blank value will let you know how it opens even before graphing. The A value, that's right. The A value. I want to put A in quotations, that way don't people think it's the oh, he misspelled something, right? It's the A value will tell you how it opens up or down. So that makes total sense. Like if I had y equals negative 2x squared, I know it's going to open down. It's going to be a little bit more narrower than your regular U-shaped curve. And that does have a maximum value, right? If you throw something up in the air, it's going to go up, reach a maximum value, and then come back down. That has a highest point, right? Or if you have a parabola that's opening up from left to right, it has a lowest point. So the highest or the lowest point all depends on if it opens up or if it opens down. And the A value tells you if it opens up or down. Okay, let's continue reading here. Right through the blank exists a vertical line that divides a parabola perfectly in half. Right through the what?
The A.
Vertex. Ladies and gentlemen, your vertex is your most important point. Why? Because it's either the highest point or the lowest point. It's the point perfectly in the middle of your parabola. Once you find that vertex, you could draw a dotted line and call it the axis of symmetry, and that'll provide you a way of reflecting points, which will save you a lot of time. Well, I guess I answered the next one already. I'm sorry. This line is called the axis of symmetry. And what could we use that axis of symmetry for? We can use it to reflect what? Coordinates. Or points, whatever you want. Coordinates or points. So I'm going to go with coordinates. So once you have your vertex, so like let's say, I'll just give you a rough sketch here. Let's say you found your vertex is right here, right? And then you draw your axis of symmetry right through that vertex. And then you make an XY table to find more points. So like let's say you find a point right here and right there, then you just map it over to the other side and you'll have your complete parabola. That's just a sketch, right? Anyway, number 2, the vertex formula is x equals what? Negative b over 2a. Perfect. And it will provide you with the x value. That's why it says x equals. How do you find the y value once you already have the x? Plug it in. That's what we need to write. Plug in the x, comma, to find y. Plug in the x to find the y. So ladies and gentlemen, your most important point of a parabola is the vertex. How do you find that vertex? With the vertex formula, x equals negative b over 2a. Once you have that x value, you plug it in to find the y value. Then you'll be able to graph it. Once you graph it, you could draw your vertical line called the axis of symmetry, and then you could use an xy table to find more points. Use the following quadratic function to answer the following. I use following too many times there. 3a. Does the above parabola open up or down?
Up.
Why?
Because it's a positive A.
Up, because the a value is 2. That's right. The a value is positive. It has to open up. Perfect. 3b. Knowing this, knowing that your parabola opens up, will you have a maximum value or a minimum value?
It's going to be a lower.
It's going to be a, okay, you said lower one. What does that mean? A minimum, right? If it opens up, that means from left to right, you're way up here. From left to right, it's going down, going down, going down, and then it reaches a minimum value, and it continues to go up. Okay, so it's a minimum value if it opens up. So this guy is minimum. If a parabola opens up, it cannot have a maximum value. Think about what maximum actually means, right? Maximum means that it's like the highest possible point. Like it actually reaches a maximum value. So if you're going from left to right right here, does it ever reach a maximum value? No, it continues to go up forever. So if it opens up, it does not have a maximum, it has a minimum. If it opens down, then you have a maximum value. If you throw something up in the air, throw it up in the air, it's going to reach a maximum value and then it's going to come back down. right? So if it opens down, maximum value. If it opens up, minimum. And you can determine all that just by looking at your A value. All right, 3C, find that maximum or minimum value, show your work. Wow, so if they tell you to find the max or min, and we just said it was a minimum, we want to find that minimum value, they're really asking you to find the what? The vertex. The vertex is the max or min, right? So let's find the vertex. How do I find the vertex, which is a coordinate, an x value and a y value? How do I find that vertex? How do I find the vertex?
The middle of the, or no, you make it.
Yeah, okay, yeah, it's the center point of your parabola, but we don't have the graph yet. Negative b over 2a. To find the vertex, you need the vertex formula. So let's write down the vertex formula. X equals negative b over 2 times a. And when we use a formula, we're going to use parentheses instead of the letters. So the b value is what? I just wrote it up here. 16. So you're going to plug in 16 in place of the b with parentheses, and you're plugging the a value of what? 2. So what do we have here? We have negative 16 divided by 4, which is negative 4. What did we just find right here?
The A.
Yes, the x. We found the x of the vertex. That is negative 4, ladies and gentlemen. Now, that's just the x value of the vertex. That's just half of the vertex. You need the y value to know the precise location of the vertex, right? So how do I find the y value if I already know the x? You plug it in, right? So again, negative 4 is x. It said x equals. We found out that x equals negative 4. So up here on the original, we're plugging it in into the x's because x equals negative 4. I'm going to plug in negative 4 right there with parentheses. I want to do that right next to it. 2 parentheses squared plus 16 parentheses plus 31. And we are plugging in a negative 4 right in those parentheses. And then I want to use my brain and a calculator, right? Negative 4 squared, that's 16. 2 times 16 is 32. Okay, it's going to get kind of ugly. Let me write over here, 32. And then 16 times negative 4, negative 64. And then bring down the plus 31. And then with the calculator, let's go 32, take away 64, plus 31. And that'll give you a negative 1 as an output. So when you plug in your x value of negative 4, you're going to get out a y value of negative 1. So that is your y value of your vertex. So that minimum value is at the location 4, negative 1. 3D. If you wanted to graph this parabola, you need more coordinates. How could you find them? XY table. Perfect. So let me just do a sketch here. Here's my XY plane. I already know that negative 4, negative 1, I already know that this is my vertex. I would draw an axis of symmetry right through it. And then if I needed more points, I go to an XY table and I plug in some values. Now, this brings up a very important moment of the lesson. What numbers would be good to plug in to my x's? And I might as well write down the function over here again. It's y equals 2x squared plus 16x plus 31. That way we could just focus in on this part right here. All right, so what numbers would be good to plug in for x? We could plug in any numbers we want. Give me a number. 7. 7 would be a horrible number. Okay? And I'll tell you why. Check this out. If I go 7 squared, that's 49. 2 times 49 is 98, right? And then plus 16 times 7, that's a huge number. Plus 31, even bigger. Okay, now, even 2. Now, check this out. If I plug in a 2, 0 is even kind of high.
Negative.
Now, let me show you why. If I plug in 0, 0 is great. 0 is great. You know why? Because when you plug in 0, it's really easy. 0 squared is 0. 2 times 0 is 0. 16 times 0 is 0. 0 plus 31 is 31. So if I actually plugged in a 0, I want to get out of 31. Imagine trying to graph that, right? 0, 31.
Negative 2.
No, that's not going to work.
So, guys, here it is. Here it is. Here's the money part of the lesson. If you have, when you find your vertex, whatever the x value of your vertex is, you want to pick values that are right next to it, close to it. All right? So what number would be a good number to plug in if the x value of my vertex is -4? -3. And which other number? -2. Right? So a -3 would be good. A -2 would be good. Okay, so I need you all to understand this. Whatever your vertex x value is, you want to pick points that are close to it. Now, if you guys are still confused, check this out. Let me go to our original parent graph, y equals x squared. The y equals x squared looks like this. Has a vertex at 0, 0, a coordinate at 1, 1, has a coordinate at 2, 4, and a coordinate at 3, 9, right? And then you map it over to the other side, and you have this parabola. So all that's saying, 1, 1, 2, 4, 3, 9. If you plug in 3 for your x, 3 squared is 9, right? This is a basic parent graph parabola. I know it's ugly, I'm sorry. But my vertex is what on the parent one? 0, 0.
Always go up 1, 2, 3, and then you...
Yeah, wherever your vertex x value is, you want to pick values that are close to it. Would it be smart to plug in 10?
No.
Why not? Because 10 squared is what? 100. I mean, it exists, but it's going to be way off your graph paper, right? So you always want to pick values that are close to your vertex x value. Does that make sense?
Yeah.
So check this out. Like let's say I had 1, 2, 3, 4, 5, 6. Let's say I had a parabola right at the coordinate 6, 0. The vertex is 6, 0, right? And you wanted to find more points. What would you plug in? 7 and 8, or you could have plugged 5 and 4, right? Either 2 above or 2 below. Why do I say either 2 above or 2 below? Because the axis of symmetry will allow you to map it over to the other side. Okay, so wherever your vertex x value is, you want to pick values that are close to it. So check this out. Let me show you that I'm going to plug in the -3, and we're going to get actually a nice coordinate somewhere around here. So to do that, we go 2 parentheses squared plus 16 times parentheses plus 31. And we're plugging in a -3 right in there. And with the calculator, you could do -3 squared. That's positive 9. 2 times 9 is 18. 16 times -3 is -48. And then plus 31. With the calculator, let's do 18 minus 48 plus 31 equals, you get positive 1 as an answer. So you see, when you pick values that are close to your vertex x value, you get nice coordinates. -3, positive 1 is right here. So you will be able to map it over to the other side, and you'll have coordinates that are nice. Make sense? Okay. This class opener has gone way longer than what I wanted to. So what I want us to do right now is take a look at our notes from Friday. And I want to start this on the next video. We got this far on Friday. We're going to continue on these notes on the next video.